This is reserve problem 18 in chapter 7. Dupliflex has a process with 3 operations that are performed in series. Because of the nature of the process, machines frequently fall out of adjustment and must be repaired. To keep the system going, 2 identical machines are used at each stage. Thus, if one fails, the other one can be used while the first one is being repaired. We have the picture and of the system, and we have the reliabilities for each of the components. Question 1 or A says analyze the system reliability assuming only one machine at each stage. So all the backups have failed. So this is simple. This is just a simple 3 components in a series. So R sub A, R of A, or reliability of A times reliability of B times reliability of C. And part B says, what is the system reliability if a B fails and only one machine B is functioning? So now we are assuming A and C are working in parallel, the 2 components of A in parallel, 2 components of C in parallel, but then B has failed, so the parallel A and the single B and then the parallel of C are in a sequence. So in this case, we have reliability of the system is reliability of, let's call this I. This is Roman numeral 1, 2, and 3. So okay, but what is reliability of system 1? Well, since we have 2 A's in parallel, we need to first find out what is the failure for one of them. So that's 1 minus 0.91. Because the reliability of A is 0.91. So 1 minus 0.91 is the failure of 1A, but that's must be squared because we have 2 of them. And then that's the failure, so 1 minus that is the reliability of subcomponent 1. And then we have reliability for 2, which is 0.87, since there's only one B that's functioning, and we'll write reliability for the C parallel the same way as we did the first one. So that's 1 minus 0.94 squared. And so if you multiply R sub 1, R sub 2, and R sub 3, then we have our system reliability. So let me bring this over here, and I will erase these. Okay, so over here we have probability of A, B, and C. If we multiply them, you can see over here the product of the 3 equals 0.744, and this is part A. And part B is over here. The answer is this. And for each of these, we can see the reliability is computed as the failure squared subtracted from 1. The same thing is for C, failure squared subtracted from 1, and this is the product of the 3. So when we go to a redundant system where A and C are working and only one B is working, then our reliability of the system increases by about 0.12. So that's 12%. So that's pretty good. Okay, thank you.